Okay, let's go ahead and continue on with the practice test. This is problem number 6, and it says for the functions below, answer the following questions. What is the location of the vertex point? Is the vertex point a minimum or a maximum? And what is or are the x-intercepts? This first one here is an absolute value function, and since the leading coefficient is negative, that means that the absolute value graph is going to be opening downward. It's going to be a V opening downward, so that means that the vertex point is a maximum. You can find the vertex point by setting the expression that's inside the absolute value equal to 0. If you set x minus 5 equal to 0, you get x equals 5. So 5 is the x part of the vertex point, and 7 is the y part of the vertex point. So the vertex point would be at the point 5, 7. Now to find the x-intercepts, you could set it equal to 0 and solve it. And we could do that by hand, or we could use the Excel sheet to help us out here. Let's see what we can do here. This particular problem, let me scroll up here so I can see it. This particular problem, can we solve it right here? Yeah, I think we can, because setting this equal to 0 right here, we can think of taking the 7 to the other side, and that would be negative 7 on the other side. So negative 7 then is playing the role of the number on the other side of the equation. Well, putting in my coefficients then, my A is negative 3, my B would be 1, my C is negative 5, and my D is, let's scroll down a little bit, and my D is the number on the other side, and I had to take the 7 to the other side of the equation, so that'd be negative 7. And I get these two right here as being my x-intercepts. Now you could also do this problem over in the graphing area of the absolute value sheet. I'm on the absolute value sheet. And if I go over here to where I can graph these, let me just move it back over here a little bit. And let's see that equation one more time. The A would be negative 3. Here we don't have to move anything to the other side. There is no quadratic term underneath the absolute value sign, so the B would be 0. The C would be 1 because there's one x right there, and the minus 5 is the D. The E would be 0, and the F, the constant at the end, is 7. If I do that, then let's see, I can put 0 in for the y value, and it gives me the same answers right here. To find the x-intercepts, put 0 in for y. It gives me that answer. It doesn't tell me what the location is of the vertex point, but if I look around 5, 7, I'll tell you what. Let's start at 4, just a little bit before 5, and go to 6. If we look at this graph from 4 to 6, and let me scroll it over. You can see here's the vertex point right there. Now, how far over is it? Well, unfortunately, the number line doesn't show up there, but it's 1, 2, 3, 4, 5 over and 7 high. Oh, there's the number line right there. 5 over, 7 high. So the vertex point is at 5, 7, and it's opening downward. Okay, long time on that problem. This problem, again, you could do it on Excel or just set the what's inside the absolute value equal to 0. And if you do that, you would take the minus 5 to the other side, then divide by 4. So you get 5/4, or 1.25 comma negative 1 is the vertex point. And since this is a positive number, it opens up and it would be a minimum. And again, you could solve this one on the same sheet, or you could take the minus 1 to the other side and use the left-hand side of it. This one's really messy. Let's do this one. This graph is going to have like 2 vertex points, so it's really messy. So let's go ahead and do that. We would get the vertex points by setting what's in the absolute value equal to 0. That would give us the x part of the vertex points. And this one is actually going to have 2 vertex points. So it's really going to take some work. I hope it's not too hard for everybody here. So here. Okay, I got the Excel sheet open here, and I can put in my coefficients for this problem. And let's see, the A would be negative 1, the B would be 6, the C would be negative 13, the D is 6, the E would be 0 because E is the number in front of the x if there's any outside of the absolute value, and then the constant at the end is 1. And now to find your x-intercepts, substitute in 0, This tells me that it looks like these are the possible x-intercepts, because you put in 0 for y to get the x-intercepts. Let's take a look at this graph from, let's go from about 0 out to about 2, since I'm looking and seeing that the smallest x-intercept says is 0.5 and the highest is 1.6. So if I look at this from, let's say, 0 to 2, let's see what x-intercepts we have here. And it does look like there's one at 0.5, there's one out here about 1.6 or so, and also there's one at 1, and there's one a little bit after that, which is your 1.16. So that's all your x-intercepts. Vertex points are here and here, and again, you would get to solve those vertex points by noticing that it's a quadratic. Go to the quadratic sheet and set it equal to 0, or just find the x-intercepts of this part right here, and you'll get it. Okay, on this one, this is a radical equation, and to find the vertex point on this, same idea, set what's underneath the radical equal to 0, and if you do that, you would get 1 for the x, and minus 3 is the y part. So the vertex point is at 1 minus 3. This is going to be the top half of a sideways parabola, so it does open up. And we could graph this if you wanted to. We could graph this on the radical sheet. Let me do that a second. So let me switch over to the radical sheet. Okay, I'm pulling off my coefficients onto the radical sheet. I would see that the a is 0.5, so let me go ahead and put these in, 0.5. The root, well, that's the square root, so the b is 2. The c is 1. The d would be minus 1. And let's see, what else do they have in here? Well, we have a, let's take a look here. We got a constant at the end. So let's get that. The e is 1, by the way, because it's to the first power underneath there. The x minus 1 is to the first power, so that's why the e is 1. Then finally, the f is minus 3. If we put that in here, I think this actually tells us the location of the vertex point 2, which is at 1, negative 3, which we had before. And the x-intercept, well, let's put in 0 for y, and it may not have any. No, it does, at 37. So way out on this graph, it will hit the x-intercept at 37. It's opening up, as you can see, and it does have an x-intercept because it started off below the x-axis. Okay, let's check the next one out here. And this one is again a radical. So we'll put in our coefficients here of negative 1. And then the b, the root, is 3. This c is 3. The d is 9. The power that this thing is raised to here is 2. And the constant at the end is minus 2. And if we do all that, we can get the graph of this. And the graph of this, well, let's take a look at what the x-intercepts are. So let's put in 0. Looks like there's no x-intercepts on this one. And the vertex point is at negative 3, negative 2. So let's take a look at this thing, back it up a little bit. Let's go back to an x value of negative 3 to see what this looks like. And if we do that, see there, it just is like the bottom half right here. Let's take a look at this beyond negative 3 to the left, like negative, clear over to negative 10. And what you can see is that this is the other side of this graph, but still it doesn't have any x-intercepts on it. And there's the vertex point right there.